Alright guys, again, welcome back to video number 3 for test number 3, cumulative review. Number 21, my goal is still to get the bars alone. Now this 6 in the front needs to be moved first over here so that we can start to get the bars more alone. Now don't let this negative fool you. The 6 is positive. So to move it to the other side, you would subtract 6 on both sides. You would get negative 4 times the absolute value of 2x minus 2 is less than or equal to negative 4 minus 6, negative 34 minus 6, which is negative 40. Now right now, you might recall from class that this looks like it's a less than problem, but the bars are not alone yet. So if I divide both sides by negative 4, I would get that the absolute value of 2x minus 2 is now greater than or equal to 10, because the inequality flips because we divided by a negative. And now that the bars are alone, this problem has a whole new meaning. I'm going to write a note that, again, remember that nothing really matters until the bars are alone. Because this flipped, now this says that this is a great or problem. So that means that when I split this into two possibilities, we have to have the word or in the middle. So either 2x minus 2 is greater or equal to 10, or the number in here, if it originally was negative, 2x minus 2, because if this was originally negative, we need to divide the negative out, and when we did that, this becomes less than or equal to negative 10. So remember, either what's inside here is positive and everything stays the same, or what in here is negative and the inequality flips and so does the sign. So if I solve these both separately, this first one, if I add 2, 2x is greater than or equal to 12, x is greater than or equal to 6, or add 2 here, 2x is less than or equal to negative 8, divide by 2, or x is less than or equal to negative 4. So this is my answer algebraically. In terms of a graph, I hope, if this is an absolute value one, I hope this or looks like it's supposed to. 5, 0 in the middle, 2, 4, 6, negative 2, negative 4, negative 6. X is either greater than or equal to 6, which would be closed dot and up, or at the same time, it could be less than or equal to negative 4, closed dot and down. So because you can choose to go this direction or this direction, I would say that my graph matches my algebra, so I know I'm correct. Number 22, my goal is to get the bars alone. This time I have an equation again, not an inequality. But still, if I want to get the bars alone, I'm going to add 3 on both sides. So I have the absolute value of x plus 1 equals negative 7. Now, just like the earlier example, this negative should give you pause. And what this says right now is distance is negative. This is never true, which means my answer is no solution. And that also means that my answer here would remain, or my number line here would remain blank. All right, the last type of problems, graphing lines. So right now, we can choose to either graph using x and y intercepts or graph using a table. And in class, we talked about the differences actually between 23 and 24 are how you would approach it. 24 looks like it's in the format ax plus by equals c. So because this is in standard form, I would suggest doing this one with x and y intercepts. 23, on the other hand, because it's more in the y equals mx plus b form, we are still graphing with tables at this time, so I would suggest doing 23 with a table. And here's what I would do for that. Let's name this x and y. And we talked about in class that because this number that we're multiplying by x has a 3 in the denominator, that means we're really taking this number and dividing by 3. So I'd only choose things here that are divisible by 3, like negative 9, we could even probably start a little bit higher. What if we did like -6, -3, 0, 3, 6. I usually like to do a little bit of negative and a little bit of positive with 0 in the middle because 0 is the best thing to plug in or the easiest thing to plug in. So what I'm going to do is plug in each of these x values into my original equation. So if I want to find y, that would be -4/3 times -6 plus 5. Now what I'm going to do for the sake of room here is I'm going to erase these just so I can show my work more. And I'll bring them back in a little bit. So this is really -4/3 times -6 over 1. So this, 4 times 6, is 24/3 plus 5. 24/3 is really 8 plus 5. So my input value is -6, and my output value looks like it's 13. So my first of the 5 points is in -6, out 13. So I might as well graph that. -6, now this only goes up to 10, so let's do the best guess we can. I'm guessing the point's going to be somewhere up here. The next value I had before to plug in was -3, because it's also divisible by 3, because we're plugging everything, and let me rewrite it down here, into y equals -4/3 x plus 5. So if I take -4/3 times -3 this time, plus 5, that is the same thing as -4/3 times -3 over 1. -4 times -3 is positive 12 over 3 plus 5. 12 divided by 3 is 4. So this is really 4 plus 5, or 9. So my next point is I plugged in a -3, and I got out a positive 9. And so if I graph that up here, over 3 up 9 would be here. So far it looks like these could be in a line. Let's keep going. My next favorite point is 0. So if I plug 0 into this equation for x, I would get -4/3 times 0 plus 5. Anything times 0 is 0. 0 plus 5 is 5. So if I plug in a 0, my output value is 5. So if I graph that, looks like so far things could be in a line. Now this one I estimated. Let me go back. -6 up here. I would say this is a good guess, but let's do one more point just to make sure. Let's also plug in +3. So if I take the 3 and plug it in here for x, we would have y equals -4/3 times 3 plus 5. Remember, this is really 3 over 1. And I didn't remind you about this up here, but remember, if there's a 3 on top and bottom, they cross out. So it's really -4 plus 5, which is a positive 1. So for my fourth point, I plugged in a 3, and I got out a 1. So I hope if I did this right that it lines up with what I have. Over 3 up 1, I would say looks like it's in a nice straight line here. So if I connect all of my points, again, sorry about not being perfect, if I connect all my points, that would be the equation of my line graphed. Now, as you can see, tables I know are a little bit tedious, but it's really good for practice with the order of operations. So if we look at 24, because this is in standard form, let's do x and y intercepts. And this time, I will do it more quickly with the cover-up method. So if I want to find my x-intercept, I'm going to cover up the y. So if I cross that out, I would get the equation 2x equals 21. Let me erase that. If I want to find my y-intercept, on the other hand, I cover up the x this time. And if you do that, picture just your finger over that rather than me crossing out, we'd have -7y equals 21. Erase that. So if I solve these both separately, if I divide both by 2, 21 divided by 2 gives me 10.5. And if I divide both of these by -7, that will give me y being -3. Now remember, these are two different points. this is where it hits on the x-axis. So here's 10, so 10.5 is just a little bit off of that x-axis. And y is -3, means it hits at -3 on the y-axis. Remember, in order to get full points for this needs to be written as a coordinate, 10.5, 0. And this is written on the y-axis as the coordinate 0, -3. Remember, as a memory trick, the x-intercept, y is 0, which is why the value here is 0. To find the y-intercept, the reason the cover-up method works is because x is 0, so that makes sense why 0 is in the x position in my coordinate. So because I have these 2 points graphed, my final line would be connecting dot number 1 and dot number 2, one on the x-axis and one on the y. Number 25. Looks like it is not in standard form, so I'm going to go ahead and make a table for this one. Because I'm not dividing by anything, my favorite values to pick are -2, -1, 0, 1, 2. And I'm going to plug them all into this equation. If I plug -2 in here, that's -3 times -2, or +6. So my first point is -2 in, 6 out. So -2 up 6. Point number 1, graphed. If I plug in -1, it's -3 times -1, or a +3 out. So my next point is -1 in, +3 out. If I plug 0 in, -3 times 0 is 0. So my third point is 0, 0. My fourth point, -3 times 1, is -3. So if I plug a 1 in, then I go down to 3. And last but not least, if I plug 2 in, -3 times 2 is -6. My last point is 2, -6. So I purposely made all the dots different so you could see what work went with it this time. So if I connect all of them together, this would be the equation of my line graphed. Last but not least, we have the equation y equals 4. So remember in class, whenever you have an equation that you're not sure what to do with, I would rely on a table. So let's think about what this means. This means that the only thing I know is that y always equals 4. So that means no matter what, my y value, again, is always 4. So it doesn't give me any restrictions on x, which means that x could be literally anything I want. It could be a fraction, could be a decimal. But to make your life easier, let's just make up 1, 2, 3. So if I graph these points, 0, 4, 1, 4, 2, 4, and 3, 4. 0, 4, 1, 4, 2, 4, and 3, 4. Looks like my dots are all making a perfectly horizontal line. I like when I said that, I had a little dip in my graph. My apologies about that. But that will be the equation of y equals 4. On the same graph, why not, because I have a few minutes here, what if I asked you to graph the equation x equals -2? So this is not what you had in your review packet, but why not do it? If I asked you to graph this, what this means is that x is always -2, no matter what. So I would plug in -2 as many times as I want, and this time the y has no restriction. So if I picked the same values, 0, 1, 2, 3, and I wanted to graph this one, it would be at the points -2, 0, -2, 1, -2, 2, and -2, 3. So this time, if it was x equals a number, my graph would be perfectly vertical, going through the x value of -2, versus this one, it goes through the y value of 4. Which again makes sense, because this is where on the graph the y equals 4, and this is where on the graph that x equals -2. All right, guys, I hope these videos were helpful. Feel free to come in with questions, and best of luck studying for this test. Thank you.